So question 4 asks us to consider this following reaction here. And to calculate the equilibrium concentrations for all substances in the above system if 0.1908 moles of CO2 and H2O were present in a 2-liter reaction vessel initially. So this is a keyword here. Initially, we do not have equilibrium concentrations, so we have to do a Rice table. So we start with our balanced reaction, which it already gives us, CO2 plus H2 yielding carbon monoxide and water vapor. So we have to get our concentrations, 0.1908 divided by 2, because we have to have moles over liters for our concentration, our initial amounts here. And we start with 0 products. Now remember, we're going to lose some reactants and we're going to gain some products. And we combine initial and change for our equilibrium row. So we then write our equilibrium expression. So KEQ equals the concentration of our products over the concentration of our reactants. So let's go ahead and plug everything in our equilibrium row into our equilibrium expression. We do have a KEQ of 1.2 times 10 to the negative 4 equals, we have X times X up here. And then down here, we have 0.94954 minus X, excuse me, times 0.0954 minus X. So would you agree with me that we could say that we have X squared on the top and we have 0.0954 minus X squared on the bottom. So if the reactants, or if the top and the bottom are raised to the same power, X stays. So we're going to take the square root of everything here. I'm going to move it up here to the top so I have enough room. And we're going to take the square root of 1.2 second E negative 4. That's going to give us our K value squared, square rooted. And I'm going to just write a few numbers down, not mess with sig figs quite yet. And I'm going to have X over 0.0954 minus X. So now I have to multiply both sides by this. So I'm going to have 0.010954 times 0.0954 minus X is equal to X. I got to distribute this number to both sides. Oops. So I have 0.001045 minus 0.010954 X equals X. I got to get my X's on both sides. So I add this to both sides. 0.001045 is equal to 1.010954 X. And this is a 1 because if there's not a number in front of the X, that's 1X. So now I got to get X by itself. I divide both sides by this number here. So I'm going to have 0.1045 divided by 1.010954. I'm going to get X is equal to 0.00. How many sig figs can I have? 3 sig figs. 103. Now, this is not my answer because it's asking for equilibrium concentrations. So then I have to plug this back into my equilibrium row. So I know that the concentrations of carbon monoxide and water vapor are equal to each other, and they are both equal to X, 0.00103. And my concentrations of the CO2 and the H2 are going to be equal to each other, but I have to subtract my X from 0.0954. So 0.0954 minus second answer, and I get 0.0944. And that's my final answer here. Concentrations of everything.